Welcome back to part two of our series where we're talking about class objects. So in our previous video, we talked about the idea of what is a class supposed to be doing. So a class object, why are they important? Why even use them, right? They're obviously, or at least ideally, they're solving some type of problem. And we found out, generally speaking, it's this idea of bundling functionality with data, right? And so anytime we try to represent something complex, there's generally we can take that object and boil it down to two components, right? Which is the attributes, so the things that describe it, and the functionality, so the things that it can do. We also then talked about, instantiating a class, methods, attributes, and just a little bit more of the finer details. Some were more formal definitions than others, but hopefully it wasn't too confusing. That's always the goal. And so now that we have I would say at least a somewhat of an understanding about class objects, we're now going to start moving into our next topic. So our next topic is instant variables in classes. So generally speaking, instant variables are for data unique to each instance, and class variables are for attributes and methods shared by all instances of a class. So let's just do an example. We'll create a new class object and we'll call it dog. We will then give it some attributes. So we will give it a shared attribute. So create a shared attribute with every instance of the dog class. This instance or this shared attributor will be called species. And then this will be canine. So every time you create a new instance of our dog class, every instance will have something that is shared with every instance. And that shared attribute is the attribute species. In this case, it is canine. We will then have attributes that are unique to every instance with that particular instance. So unique with every instance. So create a unique attribute with every instance of the dog class. In this case, we will use the double underscore init method to say, hey, every time we create a new instance of our wonderful dog class, I want to give it an attribute that is unique to that instance. So we precede it with the self keyword and we say its name. So it's just the name. So every dog is considered a canine, but every dog can have different names. Now, there's nothing stopping me from creating two instances of a dog and both naming them Joe, but the idea is that that name attribute is unique to that instance. It's not shared between anybody else, where species is shared. So anytime you create a new instance of a dog, you have this attribute that it will always be there and it will always be canine. So with that being said, let's spin up two instances of the dog class. So we'll say dog1 will equal dog. This one will be called John. Then we'll have dog2, and then this will be Mark. And then I have some stuff in my other one. I'm just going to use that. This is just save me some time typing. All we're going to do is we're going to print out dog1 name and dog2 name, and then we're going to print out the species for both. So we should see that these are unique to that instance, but they both share that unique attribute, or sorry, that shared attribute, species. So why might this be important? Well, I think when it comes to class objects, generally speaking, you're trying to, sometimes you might create different types of class that represent different types of things, but generally speaking, they fall into categories. So you can use the idea of a category to help kind of define that unique class. So even though that class has, even though that class is different from another one, it still has something that's unique about it and that you want it to be shared across every instance of that class because it's trying to represent the idea of that class. So we'll see later, but we can make this more broad and we can say, hey, maybe we want to do a cat class and we'll call it a feline, right? So even though it's weird because in a sense, they still are sharing some type of uniqueness about it in the sense of like they both have a species attribute, but it's differing from each one. And so the idea of a species is associated with that class. And I would say that's kind of the shared part, but that species attribute can kind of differentiate a little bit. But even then, within that unique subset of that class, you'll still have it every instance. So that's kind of the way I like to think about it. I think it's trying to help create a structure and a hierarchy to a certain extent, and it's trying to say even though they can look very similar, they actually do have something that's kind of shared but somewhat unique to that instance. I think here with the simple one, it's just the idea that anytime you create an instance of a dog, it's always going to have that species defined as canine, but then you can kind of create some uniqueness about that instance by saying, oh, I want it to be a name and I could have an age maybe, and so on and so on. So yeah, it's pretty neat, right? You can have an attribute that's unique to each instance, but also shared across all instances. However, it's really important to understand what it means to be shared. In some cases, this could have unintended consequences if we don't think through our problem we are trying to solve. Imagine I create a shared attribute called tricks, which will be a list of all tricks a particular dog can do. In this case, it probably doesn't make sense to have this be a shared attribute because tricks are unique to each dog, right? I can teach my dog how to, jump up in the air and, that's a unique trick. But I can go to my parents' dog and I'd be like, well, I'll teach it to play dead and that's unique to that one. So the idea of tricks doesn't really sound unique. It sounds like it's something, it doesn't sound shared. It doesn't sound like something that's going to be consistent over every instance. It sounds like it's going to be unique to that instance. So there can be some consequences if we don't define things right. So say, for example, I take my class object that represents a dog and I add some components to it. So now I'm going to create a list to store all the tricks I teach my dog. And it's not that I hate cats. I mean, I'm sure some people are at this point in the tutorial are going like, we get it. You don't like cats. It's not that. It's just the example was dogs. And I thought, dogs. Okay, so tricks. It's going to be a list. Nothing hopefully that's catching your eye here, but that's kind of odd. So now we're saying this is a shared attribute with every instance. Okay. And then we want to do learn tricks. So I want to give it some type of functionality where I can teach my dog a new trick. And so what I'm going to do is I'm going to say, okay, just create a method called learn trick. And I just pass through a trick. And then I'm going to say, okay, take my self.tricks dot append. I'll do trick. So let's take my wonderful little thing right here. And we will put it down below and start teaching our dog some tricks, right? Actually, I think in this case, I'll take these ones down here. All right. Maybe I shouldn't do that. There we go. Okay. So I create 2 new instances of my dog like I did right up above. So I still have John and Mark. I teach John to bring the remote. So that's John's trick. And then I also teach Mark change my tail. Oh, sorry. Chase my tail. And so let's see what happens, right? So ideally, we should only see this one with Mark. But we didn't set it up correctly. So here's the problem. Because we created it as a shared attribute, we now are saying it's going to be the same across every instance. And so this has unintended consequences because now the uniqueness has been taken away. And we're saying that any trick I teach to any of my dog instances will inherently, every dog will now learn that trick, which would be pretty cool, right? Because if I could teach my dog how to lay down, then I'm sure a lot of my coworkers would go like, that's great. My dog is now laying down and I didn't have to do anything. But we know it doesn't work like that. So even in a sense, I think this is also bringing it back to kind of a real world example, which is it just doesn't sound right. So you're telling me every time I teach any dog a trick, then every single dog on this planet will magically know that trick. No, I mean, that doesn't make sense. I mean, if that was the case, it would be awesome, but we just don't see that. So here, tricks doesn't really make sense because it shouldn't be shared. It really should be unique to any instance of that class. And so what we can do to basically fix our little situation here is we will basically copy our little class and we'll just put it down below and we'll just adjust it a little bit. So all I'm going to do is I'm just basically going to copy this guy right here. And what I'll do is I'll say, hey, this is actually unique to that instance of a class. And so when we instantiate it, then I want you to create a new attribute that is only for that instance. And so when I do that, let's see what happens. Perfect. So that looks a little bit better. So now John learned to bring the remote, but Mark didn't. And then Mark learned how to chase his tail basically, but John didn't. So now we've defined that those attributes basically, or those tricks are unique to that instance of that dog. So that's, I think the biggest takeaway from here is be careful sometimes when you start creating a shared attributes of that particular instance. Because you really want to make sure, do you really want that to exist with every instance of that particular class object? Because you're really saying it's truly unique to the idea of that class object, and everyone should be having that regardless, and that it isn't unique. It's always the same with every instance. All right. Next, notes and best practices. Okay. So make sure to not name methods and attributes the same as data attributes override method attributes. Basically from here is you don't want to have learn trick be a method and then also learn trick be an attribute. You want those to be separate. So again, that just goes back to normal naming conventions. I see this sometimes when people send me code and I get it. We've all been there. But you really do want to try to give your variables significant names. You really shouldn't assume that everyone's gonna, look at your code and magically know what's going on. I know, I know we all write it, so we know what it's supposed to be doing. You should never assume that the person reading it understands what you're doing. So again, that just goes back to naming conventions. You try to limit the amount of confusion. In this particular case, there's actually performance implications to that. So it actually will change the actual behavior of your program. So that's an issue. Data attributes may be referenced by methods as well as ordinary user. There are no private method attributes in Python. That is such an important concept. In other languages, there are methods and properties that you cannot access from that class object. So if they're defined private, guess what? You cannot access them. Python, that is not the case. There is no such concept of private method and attributes, which is really weird sometimes if you're coming from a different background, because you're all of a sudden you're like, wait a minute, like why does that make sense? Or like, hey, that just to me doesn't make sense. So that's basically the first thing. So you just want to keep in mind that there is no idea of a private method and attribute. Often the first argument of a method is called self, and then I have some notes. This is nothing more than a convention. The name self has absolutely no special meaning in Python. However, by not following that convention, your code might be less readable to other Python programmers. And it is also conceivable that a class browser program might be written that relies upon such convention. Basically, what they're saying here is there is no reason, I guess, basically in the sense of, do I have my example here? I'll check really quickly. Oh, maybe I don't. Oh, I thought I did. But basically, there's just saying, I mean, you really can name it whatever you want. The big thing is there's a lot of infrastructure out there that depends on that notation. And so if you don't follow it, there's a very good probability that your program will not work in certain environments. So simple story is just follow that naming convention and you will be fine. So in other words, just always make sure the first argument is self. It doesn't have to be. It can technically be something else, but you really need to follow that. Okay. Additionally, methods may also call other methods by using the self argument. So this is actually kind of neat. I'm going to create a new class object. I'm going to call it a range. And then with this particular range object, we'll define a double underscore init method. And then that will take the self keyword. And all I'm going to do is I'm going to have self.data, and that just equals a list. And then we're going to have one method called add value. That will take self and then some value. And then all I do is I just append that value to my self.data. So I'm just appending it to a list. And then I can also define another method called add value twice. And really this is doing the same thing up above, but I think kind of just to make my life a little bit easier is I'll just call the self dot add value method and then just pass through the value. So here's kind of something neat, right? I can actually call that method from within my class object. I just have to basically proceed it with the self argument. That's pretty much it. And then once you do that, you're good to go. The important idea here is that you can call that method from within the class object itself. Nothing's stopping you from doing that. In fact, it's actually very advantageous to do that because I do that all the time. So what I'll do is I'll define a new instance of my range object, and I'll say my range equals a range class object. Add a single value. We'll do my range, add value, and then we'll do 100, and then add a single value twice. My range, add value twice. And then we'll do my range, and then we'll print out that data. Hey, look at that. And just to give you proof again. So again, it's showing that there was no syntax errors. So again, it is, it's basically just trying to demonstrate the idea that, again, you can call a method from within an instance of a class by itself. There's nothing stopping you from doing that. One sec while I take a water break. Okay. Whew. Sorry, I have to do that now or else, like, I know 5 minutes in, I'm going to start losing my voice. It's actually a lot better, though. How much time do we have? Yeah, we'll do this last one. It's an important topic, but I think it's also... I actually think if you come from a VBA background, it's actually a little bit easier. So inheritance. I took a Wikipedia definition. So in object-oriented programming, inheritance is the mechanism of basing an object or class upon another object, prototype-based inheritance, or class-based inheritance, pertaining similar implementation. A more quote-unquote real-life definition would be to imagine this concept from a biological perspective. in biology, children can inherit features from their parents. For example, a child can inherit features like eye color. I have blue eyes. Both of my parents have blue eyes. So I basically can inherit those genes from my parents. So I'm inheriting maybe one from my dad and one from my mom, but I can inherit from some parent. Using our biology example and converting it over to our programming world, we have a parent class. So we'll call this mom or dad. And then we also have base class. Oh, sorry. We have parent classes, also called base classes, ancestors, superclass, and probably 5 other names I can't think of. There's a lot of naming conventions, but we'll just do an example and say mom, dad. So that's our parent class that provide the framework of the child class. So basically, the template for building the child class. So the child class, that could be me, so Alex. And they're also called subclasses, heir classes, descendants, and again, like probably 5 other names I can't even think of. So I inherit features from my parents, so the mom and dad class. This means that child classes can reuse the code from our parent class. I cheat. I take my parents' code and it gives me a nice template to build off of. So I don't have to start everything from scratch. I can just take my parents' code and look at that. I'm already 10 steps ahead. So again, this might not seem like a huge deal, but it's actually pretty important because when we think about code and reusability and maintainability, the idea that I don't have to write everything from scratch every single time I want to build a new program is outrageously important. I mean, I cannot even begin to explain the importance of that. I mean, look at all the libraries are out there. It's using that concept. It's using that concept of inheritance or all the time. And so there's been times before where I've built objects off of other objects. I mean, if you've seen my Python Net Windows Form series, perfect example right there. We're using that template and we're just simply expanding on it. So what it does is, again, it allows us to free up our time. We don't have to spend everything and write it from scratch. And it also reduces redundancies. I'm not repeating the same thing over and over again. Additionally, it also allows a vehicle, in a sense, to define some type of natural hierarchy of our code. So that's actually important because a lot of times when we look outside, there are hierarchies. Some are more apparent than others. For example, a vehicle can have a hierarchy. So you might have attributes that are kind of broad. So you'll have this like kind of broad vehicle category that defines attributes like make and model. But the idea of a vehicle can actually be a little bit more, can mean a lot of different things. Is a boat a vehicle? Is a car a vehicle? Is a bike a vehicle? So the broad idea of a vehicle can then have its own components that you can use basically as a template. So for example, I want to create the idea of a vehicle in my program. So I'm going to say, well, every vehicle, I don't care if it's a bike, a car, a boat, whatever it is, it's always going to have make and model. But then what I can do is I can also define child classes that inherit the template of a vehicle, but then allow it to give it some uniqueness. So I can then say, well, a bike, for example, might have an attribute number of wheels that's 2. So that's unique to a bike. Car and boat. So these lower level categories still share features of the higher level category like make and model, but also have unique attributes like number of wheels, turnkey, or something like that, which might not actually be shared across all instances of a vehicle class. So the basic syntax is my child class and my parent class. So I say, okay, when I create an instance of my my child class, I'm going to use my parent class as my my input, right? Side note, the name base class name must be defined in a scope containing the derived class definition in place of a base class name. Other arbitrary expressions are also allowed. This can be helpful, for example, when the base class is defined in another module. So I'm saying, hey, from my module, take, the pandas data frame as my parent class. I'm going to add new functionality to it, like, I don't know, color every other row, something like that, right? So my parent class is the data frame, but this will be my colored data frame child, right? So with that, let's do a simple example. So we'll create a broad animal class, and then this animal, define the type. So a type, so I'll say the type will equal animal, right? So an animal is an animal. Every animal will have a weight and an age. So I'll say, okay, every time underscore init method, every time you create a new instance of this class, you need to give it a weight and an age. And then what we'll do is we'll say self dot weight equals weight. And then we'll do self dot age equals age. Additionally, every animal, for example, every animal can move. So every animal, so we'll say define is moving. Every animal can move. They might move in different manners, but generally speaking, they can move. And so every time they move, it'll print out the animal is moving. Okay, so now we're gonna basically now start creating our subclasses, our child classes. So let's define a subclass called bear. Bear. Got a bear. Okay, and our bear object will inherit from animal. And then in this case, what I want to do is I'll say, hey, a bear has a more specific attribute called a species. And so again, this is shared by every instance. So shared, we'll call this a shared attribute. So we're still keeping the same ideas. We're just, again, we're making them a little bit more specific, and we're trying to implement a more complex idea, something like an animal. And then every bear will still have a weight and age, but it will also have a number of legs. So what we'll do is we'll say define underscore init. We'll do self, weight, age, number of legs. And then from here, we'll say self, number of legs equals number of legs that were passed through. And then we're going to take our animal and we're going to say, okay, init. And we're going to say self, weight, and age, right? So now we're saying we're going to take the attributes that are basically from an animal instance and assign them to our bear instance. Okay, and then in this case, this bear is going to have a unique method to it, which is going to be is running. So we'll say print the bear is running. Right? Very nice. So that's the idea of a bear. Let's also make another subclass. We'll call this one fish. So a fish is still an animal. I mean, maybe it's not. I don't know. Maybe it's not. But I'm going to consider it an animal for the time being. In this case, our species will be fish. It's still going to have weight, still going to have age. But in this case, it's not going to be number of legs. It's going to be number of fins. Number of fins. Okay, and then on top of that, well, a fish can't run, but it can swim. So we'll say is swimming. And we'll say the fish is swimming. So we've defined the instances of our class. And then what we'll do is we'll create an instance of them. So what I'm going to do is we're just going to copy some code and then we'll walk through it. Where's my bear? There it is. Okay. So here, I define an instance of a fish, call it my fish, and I define an instance of my bear, and I call it my bear. And then I have number of fins, and then number of legs. And then also I have an age and a weight. So again, these are shared, the weight and the age, but the fins and the legs are unique. And then I also say our fish is moving, my fish is swimming. So this is taking that is moving method in our animal instance. And then I have my bear is moving and my bear is running. And then my fish is swimming. And then I'm still printing out everything with it. So now we can see the animal's moving. The animal's moving. The fish is swimming. So on and so on. So pretty cool, right? I thought that was pretty neat. Um, but that's really the idea of inheritance is you're using some type of template and you're expanding on that template. So you're trying to enhance the functionality. Again, you'll kind of see this in definitely more complex applications, but the idea is that there's some type of natural order, some type of natural hierarchy. And so you can start really broad and then you can start getting more and more specific. If I want to go back to my finance world, well, I can have a broad topic of a financial instrument. So, there might have some type of component to it that's unique to it. So, for example, internal value, it might have a unique identifier. So every financial instrument will have a unique identifier and it will have some type of internal value. But then, obviously, depending on the type of financial instrument you have, there might be some uniqueness to it. So, for example, if it's a stock, it might have a category of equity. If it's a bond, it will have a category of fixed income. And then there might be, what is it? With a stock, there is uh, we'll say like there's the number of shares owned. And then, with, a bond, we'll say number of bonds owned. So it's just kind of this idea that you can start with this high level category that serves as your template. And then with that template, you can then start getting more and more specific. So I like it. I think it's kind of neat, but it definitely takes a little bit of getting used to, especially if you're new to the idea of classes. It can definitely be a little bit confusing at first. However, I think at this point I've taken up more than enough time. So if you have any questions about inheritance, methods and shared attributes and stuff like that, by all means, put them down in the comments below. Otherwise, in our next video, we're going to talk about multiple inheritance. And then actually from there, we're pretty much done. So next video is going to be relatively quick, thankfully. And then we'll go on to the next topic.